So our main goal today, and these notes are actually split into 2 days, so we're not doing all of them today. But what we are going to do is define our 6 basic trig ratios. And then we'll use them to solve right triangles. Stop. All right, you might recall from geometry that the word trigonometry means measurement of triangles. Which makes sense because we use trig to find different measures of triangles. Bless you. We can use trig to find both angle measures and side lengths. If you look at the picture that we have over here, in geometry you typically had an angle marked with an X or a Y, like just a typical variable. Now that we're in Algebra 2, getting ready for a lot of you for pre-cal, you're going to see the angle represented by the Greek letter theta. T-H-E-T-A, theta. Okay? Treat it just like you did in geometry with an X. Okay? It's just using a Greek letter. That's what you typically will see in pre-cal and calculus. Okay? And physics. All right. Just remember, based on where that acute angle is, your opposite side and your adjacent side could be reversed. Okay? So it's always with respect to that acute angle that you have marked. All right. The 3 trig ratios that you saw in geometry were your sine, cosine, tangent. We are adding 3 more to them, but like I mentioned, they directly relate to the 3 you already know. So let's review and define sine of theta as our opposite side over the hypotenuse. Cosecant is the reciprocal ratio. So the cosecant of theta is the hypotenuse over the opposite side. Cosecant is the reciprocal ratio of sine. No, it's cosecant of theta. I don't have the best thetas ever. Some math teachers do them like real pretty like, and I'm not one of them. That's some teachers' theta, but that's not mine. Just ignore it. All right.
You can erase it.
After I do certain like tools, I can't erase. Like it won't let me erase now. Look, it's whatever. Okay. For cosine of theta is the adjacent side over the hypotenuse. And then secant is our reciprocal ratio of cosine. So this is the hypotenuse. Secant of theta is the hypotenuse over the adjacent side. Again, just the reciprocal of that.
Isn't secant like a thing?
Let's do things. All right, and then finally, tangent of theta is our opposite side over our adjacent side. And then cotangent of theta, again, is just the reciprocal. You can still use, as far as like a little mnemonic device to help you remember, you can certainly still use your SOHCAHTOA. So if you know your basic 3 trig ratios and you know what pairs up together, so as long as you know, for instance, that cosecant is the reciprocal of sine, just flip those. If you know that secant is the reciprocal of cosine, just flip those, and so on for cotangent. Okay. You found my mistake. Oh my goodness gracious. That would have been tragic. That should not be adjacent over hypotenuse. That should be adjacent over opposite. Gosh darn. What we are going to go ahead and do then in our first example, we're just going to write out our 6 trig ratios, approximate them to 4 decimal places. If you look at the triangle given, however, you can see that we are missing what? So how can we find the length of the hypotenuse?
With your Pythagorean theorem.
Hence that warm-up question. So Pythagorean theorem is 8 squared plus 15 squared equals the
17.
c squared. It is going to be 17.
Well, that was the warm-up.
It was the warm-up.
No, I didn't know it was like the exact.
It was the warm-up triangle. Yes.
I thought you were
No. Let's go ahead and move on. So let's do, guys, our regular sine, cosine, tangent first. So sine is going to be opposite over hypotenuse with respect to that angle. The opposite side is what? Over the hypotenuse is 17. With your calculators, then divide 8 by 17. We're going to 4 decimal places. What is it?
0.4706.
0.4706, thank you. Cosine of theta, again, with respect to that angle, the adjacent side is 15. Your hypotenuse is still 17. Then to 4 decimal places should be 0.8824. And tangent of theta is the opposite side over the adjacent side. To 4 decimal places is 0.5333. Here's the deal. Once you have your sine, cosine, tangent ratios written out, remember that cosecant, secant, and cotangent are just the reciprocal ratios. So take the sine, cosine, tangent ratios and just take the reciprocal of them, right? So cosecant of theta would be then 17 over 8. You will have to divide that out again on your calculators. Secant of theta, again, just the reciprocal of cosine, 17 over 15. And cotangent is the reciprocal of tangent, so 15 over 8. And then using your calculators, you can get the decimals. Should that be a 3 again? Oh, it was hard. So you can write cosecant, secant, cotangent as 1 over its reciprocal ratio. Yes? Right. Let's look at and review how we can use our trig ratios to find side lengths or angle measures. We are going to start with side lengths. So here's the deal. With respect to the angle you're given, with respect to that 27-degree angle, what 2 sides are marked? The adjacent and the opposite. With adjacent and opposite, which trig ratio involves those 2? Tangent. So we are going to say tangent of 27 degrees equals the opposite side over the adjacent side. From here, here's where those little proportion problems came from on your warm-up. The best way to do this is make tangent of 27 degrees over 1, and then you can cross multiply. So x equals 10 times the tangent of 27. Now, before you use your calculators, especially those of you with graphing calculators, we need to check our mode. Yep, Brianna's face tells me that she is not in the right mode. On your graphing calculators, go to your mode button. It's on the left-hand side. Hit your mode. Scroll down, I don't know, 3, 4, 5 places. Right now, it's probably on radian. You need to go over to where it says degree. Hit enter when you're on degree to get it in degree mode. As long as your calculator is in the correct mode, you should have that the side length is 5.1. No. All right, let's look at the next one. With respect to this 39-degree angle, we have the adjacent side and the hypotenuse. Which of our trig ratios uses adjacent and hypotenuse? So this is cosine of 39 degrees is equal to the adjacent side over the hypotenuse. Again, put that over 1, cross multiply. Should be getting about 5.4. Go ahead and look at how we would find angle measures. Kelly mentioned earlier to the -1, the inverse trig, that is what we use to find angle measures. Same type of thing to get us started. With respect to the angle that we're looking for, what sides are we given? Opposite and adjacent, which is what ratio? So tangent, you can use theta, you can use angle A, whatever, I don't care. I'm typically going to use theta. So tangent of theta is equal to the opposite side over the adjacent side. And then theta will be equal to the inverse tangent of that ratio. From this point, it's all a calculator issue. Usually, your inverse trig is your second button. So second tangent usually will give you the inverse tangent. And then of 29 divided by 38, hit enter, and you should get the angle measure.
So if we're looking for sides, we use the normal ones, and if you're looking for the angle measures, you use the second.
Exactly. If you didn't hear what Alyssa said, which I'm not sure what you're doing back there, but what she said is for side lengths, yes, regular sine, cosine, tangent. For angle measures, the inverses. Absolutely. What are we getting for that? 37.3 degrees. Very good. All right. Which trig ratio did we use? Which trig ratio did we use? Sine. You have the opposite side in the hypotenuse, so sine of theta is equal to opposite over hypotenuse. So to find that angle measure, take the inverse sine of the ratio. What's our angle measure?
68.
Yeah, it rounds up to 68 degrees to the 10th. If you look at the last two examples that we are going to do today, it asks you to solve the right triangle. If you remember from geometry, what that means is you are going to find all missing measures. Find all missing measures. So you need to find every single angle measure, every single side length. Now, the best way to get these started, if you had me in geometry, which was actually quite a few of you last year, I told you this last year too. The best way to get this started, whatever you have two of, find the third. So in this case, you have two angle measures. The easiest way to start this is to find the third angle measure because you can do what?
You can just add 34 and 90 and subtract that from 180.
Exactly. You can take 34 and 90 from 180. to get that the missing angle measure is 56 degrees. Fill that in on your triangle because you can then use any measure you find again. All right, we have all three angle measures, so now we need to do some work with the side lengths. That's going back up using our trig. It is up to you which side length you want to find first. You want to do A first or B first? You want to do A? All right, let's do A first. Do you want to use the 34-degree angle or do you want to use the 56-degree angle? No, one or the other.
34.
All right.
Do it twice.
So, with respect to that 34-degree angle, if we're looking for A, that's the opposite side. And then we're given the length of the hypotenuse. So, opposite and hypotenuse is what? Sine. So, we will say sine of 34 degrees is equal to A over 24. And you can cross multiply. And we'll go to the 10th, which is 13.4. Once you have a second side length, you have some options to find the third. What's one option? You could use trig again. What else could you do? You could also use Pythagorean theorem. It's completely up to you. I don't care what you do. You'll typically see me use trig again, but if you want to use Pythagorean theorem, then go for it. I'm going to use trig though. So if I look again at my 34-degree angle and I'm looking for B, that's the adjacent side. And then I'll use that hypotenuse again. So this will be cosine of 34 degrees is equal to the adjacent over the hypotenuse. And then I can cross multiply. Everybody about has it, but the first thing, listen, the first thing that we could do, because we're given two side lengths, we can use Pythagorean theorem to find the length of the hypotenuse, which comes out to be 73. I'm going to skip the work here. You can use your inverse trig for the angle measures. So let's say I'm using or finding S. Which of our trig ratios do I have to use to find the measure of that angle? Which one do I have to use? Do I have to use cosine?
No. Just kidding.
Which one can I use? If you have all three side lengths, which trig ratio can you use? Any of them, thank you. So you just pick, let's say I pick sine of angle S. That's the opposite over the hypotenuse. And then the measure of that angle you'll get by taking the inverse sine. That should come out to be 41.1. And then once you have that, you can subtract 41.1 and 90 from 180 to get the measure of angle Q.